Okay, we're in the helicopter flying handbook, chapter 13, night operations. This will be the introduction on page 1. And yeah, we'll go into visual deficiencies. All right, introduction, night operations. Pilots rely more on vision than on any other sense to orient themselves in flight. The following visual factors contribute to flying performance: good depth perception for safe landings, good visual acuity to identify terrain features and obstacles in the flight path, and good color vision. Although vision is the most accurate and reliable sense, visual cues can be misleading, contributing to incidents occurring within the flight environment. Pilots must be aware of and know how to compensate effectively for the following: physical deficiency or self-imposed stress, such as smoking, which limits night vision capability; visual cue deficiencies, limitations in visual acuity, dark adaptation, and color and depth perception. For example, at night, the unaided eye has degraded visual acuity. For more information on night operations, reference chapter 16, pages 16 through 20, with the Pilot's Handbook of Aeronautical Knowledge. All right, page 2 of 10. Visual deficiencies, night myopia. At night, blue wavelengths of light prevail in the visible portion of the spectrum. Therefore, slightly nearsighted myopic individuals viewing blue-green light at night may experience blurred vision. Even pilots with perfect vision find that image sharpness decreases as pupil diameter increases. For individuals with mild refractive errors, these factors combine to make vision unacceptably blurred unless they wear corrective glasses. Another factor to consider is dark focus. When light levels decrease, the focusing mechanism of the eye may move toward a resting position and make the eye more myopic. These factors become important when pilots rely on the terrain features during unaided night flight. Practicing good light discipline is very important and helps pilots to retain their night adaptation. Keeping the cockpit lighting on dim allows the pilot to better identify outside details, unmarked hazards such as towers less than 200 feet AGL, and unapproved landing sites with no hazard light in. So myopic is slightly nearsighted. All right, a simple exercise that shows the difference in light contrast would be to go out to a very dark road, turn the dashboard lights down very low and off, and let your eyes adjust to the ambient light levels. Then turn the dashboard lights up and note how the outside features disappear. The same concept applies to cockpit lighting and being able to see the surrounding terrain and obstacles. Figure 13-1, special corrective lenses can be prescribed to pilots who experience light myopia. Figure 13-1, effects of diminishing cockpit lighting during night flight to better see surrounding areas. Hyperopia. Hyperopia is also caused by an error in refraction. In hyperopic state, when a pilot views a near image, the actual focal point of the eye is behind the retinal plane, the wall, causing blurred vision. Objects that are nearby are not seen clearly. Only more distant objects are in focus. This problem is referred to as farsightedness. Astigmatism. An unequal curvature of the cornea or lens of the eye causes this condition. A ray of light is spread over a diffused area in one meridian. In normal vision, a ray of light is sharply focused on the retina. Astigmatism is the inability to focus different meridians simultaneously. If, for example, a stigmat individual focused on power poles vertical, the wires horizontal are out of focus for most of them. Presbyopia. Presbyopia. This condition is part of the normal aging process, which causes the lens to harden. Beginning in the early teens, the human eye gradually loses the ability to accommodate for and focus on nearby objects. When people are about 40 years old, their eyes are unable to focus at normal reading distances without reading glasses. Reduced illumination interferes with focus depth and accommodation ability. Hardening of the lens may also result in clouding of the lens, cataract formation. Aviators with early cataracts may see a standard eye chart clearly under normal daylight but have difficulty seeing under bright light condition. This problem is due to light scattering as it enters the eye. The glare sensitivity is disabling under certain circumstances. Glare disability related to constant sensitivity is the ability to detect objects against varying shades of background. Other visual functions decline with age and affect the aircrew members' performance. Dynamic acuity, recover from glare, function under low illumination, and information processing. So that was page 2 of 10. That's your visual deficiencies in chapter 13. All right, night operations. See ya.